Hi, I want to give you a wrap up of section 8.3. I want to emphasize some of the things that Nathan went over, add to that maybe a little bit, and also probably de-emphasize some of the things he went over. First of all, this is back at the acupuncture or the sham acupuncture example. And here's the results that you should have seen in one of the previous videos. And the thing to note here is the real acupuncture and the sham acupuncture proportions of successes, where you got substantial pain reduction, were about the same in the 40%. But the non-acupuncture, which remember wasn't a true control, so it wasn't that they had no treatment whatsoever. They had medicine, they had physical therapy, and that did much worse. And you remember that was significantly worse. And we can see in the 20%, you can see it here in the segmented bar graph, the better is much lower than the other two on here. I don't think Nathan went over this. So in section 8.1, we talked about doing simulation-based methods and using the MAD statistic. So here's calculating the MAD statistic for this data set. So our three conditional proportions, 0.475, 442, 0.273, are right here. And we're finding the distance between these three numbers. And more specifically, the MAD statistic is that average distance between the three proportions. So find the differences, take their absolute values, and when I do it, I always subtract highest minus lowest number to get a positive number. So you never have negative numbers here. So find those three distances, find the average of those distances right here. So 0.135, that's the average distance between our two conditional proportions, and that's our MAD statistic. So for the chi-square statistic, Nathan went over a couple formulas, and don't worry about those formulas. Just realize that the chi-squared is another way to measure how far apart proportions are from one another. You can also think of this as how far apart the proportions are from the overall proportion of success, but also just how far apart they are from one another. The thing I want you to remember is, just like the MAD statistic, the larger the chi-square, the more evidence there is against the null. So larger MAD, more evidence against the null, larger chi-squared, more evidence against the null. And also that a chi-squared of 0 means the proportions are all the same. Just like a MAD statistic of 0 would mean our conditional proportions are all the same. There's no difference between our proportions. That's a MAD of 0, that's a chi-squared of 0. Okay, let's go to the multiple proportions applet and run this data set. I'm going to do both a simulation-based method with it, do the chi-squared with a simulation. That's something Nathan didn't do in his videos. And then I'll do theory, both looking at the distribution and then do it just like Nathan did on the left side of the screen with the chi-squared table. All right, here we are at our ISI page. I want to first get the data for the acupuncture study. So down here in chapter 9, sorry, down here in chapter 8, go to example 8.2, acupuncture. This is a large data set, so I'm going to do control A for control all and control C for control copy. So I've got that data all copied, and now I'm going to go to the applets, pick the multiple proportions, clear out the data that's in there, paste the acupuncture data in there, click on use data, because we have the raw data, not a table. And so here's our segmented bar graph. There's the MAD statistic. I can click on show table, and we can see the three conditional proportions there. Again, that no acupuncture had that lower proportion on there. And in section 8.1, we did shuffling for this. So we went up, it's kind of nice to show the plot here. I do the shuffles there, and for this case, here's a simulated distribution that you could get under a true null. Here's the simulated, pull this down, here's the simulated conditional proportions, here's the simulated MAD statistic, and of course that's collected over here in the null distribution. I only have one so far. And you can see when I hit shuffle on these, the segmented bar graph doesn't change much. We have large sample sizes, so it's not going to move too much at all. My my observed MAD statistic 0.135, you can see I'm not even close out here. I got 0.05, maybe this is 0.06 out in here. So 0.135, hasn't even happened, not even close to what happened. It's way out there. And so we're getting this p-value of 0. So here's 1,000 more shuffles and 1,000 more. I'll bump this up to 5,000. It's not going to happen. So out of 5,000, sorry, 10,000, we're up to 10,000. 10,014 shuffles. Yeah, I didn't get any MAD statistics greater than 0.135. So this is the simulation-based method we used in section 8.1. So now let's kind of segue into theory. We're not going to get to theory quite just yet. I'm just going to switch the statistic to that chi-squared statistic. So this gives me the observed chi-squared statistic right here, 83,054. I go over here and my null distribution now has changed to chi-squared statistics. And I'm looking for that 38.054. And of course, that didn't happen at all. I got nothing out that far, 38.054. Again, get this simulated p-value of 0, because I'm still using my simulated null distribution with a different statistic, a chi-squared statistic. And then when you click on this button, overlay chi-squared distribution, that's our theory-based p-value. And again, not surprising that it's also 0 to 4 decimal places. It could happen by chance, but it's very, very, very unlikely. So very small. So this is doing both simulation again with the chi-square, this p-value in red, and a theory-based with the chi-square, that p-value in gold color. And then over here on the left, this is what Nathan did. He showed the chi-squared output is right here. Here's that same chi-square statistic, 38.054 that I have up here. Here are the components of the chi-square. So one of the formulas that he went over was the observed count minus the expected count, that quantity squared divided by expected count. And so for each of these observed counts, like this 184, so it's 184 minus whatever is expected under this no association, what's ever expected there, whatever number that is, that 184 minus expected quantity squared divided by expected, that's this 6.05 down here. And you just add all these up and you get 38.054. Again, I'm not going to have you do that. I'm not going to have you calculate. I will have you calculate a MAD statistic, but not a chi-squared statistic. We're going to get that from the applet. And of course, it gives you the p-value to 4 decimal places down here. And then another thing Nathan went over are the follow-up tests. So we've got significant evidence that there is a difference. Well, where is that difference? Are all the proportions different in the long run or not? Well, we can look at a graph and see, with real acupuncture and sham acupuncture, they don't look like they're that much different, but the no acupuncture does. And that's what these confidence intervals will show us in the follow-up test. Anytime there's a none in there, those confidence intervals don't include 0. They're completely positive. Real is better than none. Sham is better than none. But on this one up here, the real and the sham, well, they're not statistically different. That difference could be negative, that difference could be positive, or that difference could be 0, meaning there could be no difference between those two. So those are the follow-up tests. So again, what I've done is I did a simulated null distribution using the MAD statistic, then another simulated using a chi-squared statistic, and then theory-based with the chi-squared, including those follow-up confidence intervals. All right, I want to look at one more quick example for section 8.2. So far, we've looked at examples where we always had a binary response variable. We've had a non-binary explanatory variable, looking at more than 2 proportions, but look at this one. We've got a response variable, and this is income level, and there's above average, average, and below average. There's 3 categories to this. So we're going to see, is there an association between income level and happiness? And we're going to investigate this with some data from the 2002 General Social Survey. So think about if we were calculating the MAD statistic here, we'd be looking at the condition proportion of successes in each group and then finding the average distance between those. But what is a success in here? It's not binary. We've got three different categories here. So I can't just take the proportion of above average income overall and compare that with above average income in this group, the pretty happy group overall, and so on with that, because I'm missing some data down here. If it was binary and say I've got a 30% chance or 30% success, then I know there's a 70% failure. But when it's non-binary, if I have a 30% success, kind of in quotes here, like above average income, I've got 70% then down here, but I don't know how it's split up. We're losing that information. So a MAD statistic is leaving out some information with this. So we can't use a MAD statistic with this, but we can use a chi-squared. Chi-squared takes into account every single cell on there. So in calculating a chi-squared, remember, it was one of the ways to think of it is this formula down here, the observed value in a cell minus the expected value in a cell under the assumption of no association. So you'd calculate those expected values just like we did with those two-way tables showing no association. Squaring that, dividing by expected, and then doing this for every cell, and then adding all those up. And again, don't worry about the formula. Just realize, what it's doing. It's finding out how far apart are those observed statistics from what we would get if there's no association for that. And it takes into account every single cell with that. So let's put this table into the multiple proportions applet, see if there's an association between there. And remember, when we put a table in, we don't put any of the totals in there. So none of the totals go in there. And the words here on the top or on the side here can't have any spaces into that. So I've already got the data copied and pasted into my multiple proportions applet. Whoops, not that one. Right here. And I have to do a little bit of editing. So instead of saying above average, I'm just going to say above. Instead of below average, I'm going to say below. And not too happy, I think it'll just be not. And pretty happy, I'm just going to make pretty. And very happy, I'm just going to make very. So I've gotten rid of my spaces that way. And then make sure I hit use table. And so here's a segmented bar graph, and you kind of see, well, the bottom part, that's sort of like we've had before. We've had three categories. That's nothing new here. But oh, look inside there. Now we've got three categories on the inside. And you can see just by looking at the segmented bar graph, do they look like they're about the same? No, they don't. Maybe these last two look fairly similar, but this one that's not happy, they have a much larger below average income on there. So a much larger group, I should say, a much larger group are below average income, and a few in the average, a smaller in the above on there. And so when I go down here, I can click on the show table again. There's the table. There's the condition proportions of the above average income. Not important because I don't need to focus on those. I don't want the MAD statistic. I want a chi-square statistic. So there's my observed chi-square statistic. I could do shuffling and everything over here. There's 1,000, there's 10,000 shuffles to this. And then again, my observed statistic is 73.352. And I can see 73.352 even before I put it in. It's way, way out there. I've got another p-value of 0 on here. And if I go over here, I can do the same thing with the chi-square output, but I guess this one's theory-based output. So again, there's all the components that get added up. We're taking every cell into account. There's the sum of that. That's the chi-square statistic. There's our theory-based p-value. We don't do follow-up confidence intervals on this one because, again, it's just focusing on the above average income. So we're just going to leave this one as to, yes, there's strong evidence of an association between income level and happiness. And we'll just leave it at that. We're not going to look for exactly where that is. You can kind of see it though in the not happy group. These are the large numbers in there, particularly in the below average income. A lot larger number that were observed in this group than what's expected, and hence a much larger chi-square statistic.